Oxford Cancer Biomarkers is using precision medicine to improve standards of care in cancer and avoid unnecessary deaths. The IBM PowerAI tools help us do that both more quickly but also more reliably. So a biomarker is something that you can measure in the body. It might be from blood, it might be from saliva or other body tissues, and it provides us insight into what's going on inside the body. Taking colon cancer as an example, the first course of action for many patients with disease is to cut the cancer out. There's then a question with regards to whether that cancer is an aggressive one and likely to cause further problems, or whether it's better to just let the patient avoid the risks of chemotherapy and just have regular monitoring.
About 1% of people are likely to actually die from fluoropyrimidine toxicity, and that's as a result of the chemotherapy that is supposed to help cure them, so it's catastrophic.
Our coloprog test looks at the tumour itself and the microenvironment around it and provides doctors with insight that helps them to make better clinical decisions and avoids unnecessary chemotherapy for those patients that don't require it.
The machine learning part of this requires a great deal of data. So in Oxford Cancer Bio's instance, they have got large amounts of pathology data, stained images, that we can then run through the system and train a model to look for certain things within those images.
What the AI is actually looking at is slices of tumour tissue. There's a huge array of possible things you'd want to know about an individual tumour. And what this allows us to do is build models to interrogate a given image and look at various different parameters of it, and from that we can pull out clinically actionable information. The first thing we did was basically see if the AI technology that we were provided access to by IBM Meridian, whether or not it could match or beat what we were currently doing. And we found that in terms of speed, it vastly outperformed the current system we're using. The honest truth is, one of the most remarkable capabilities that we've been able to access through this is the ability to rapidly prototype ideas. I mean, we can think up an idea one day, build it the next, test it the day after.
So that's the beauty of this system, really. They don't need a data scientist, they don't need somebody who's a technologist to help them deliver their algorithms, their models against their data.
Without IBM PowerAI Vision, I need to spend lots of time to tune the neural network, to make the work, to classify the nuclei. For me, that will take a huge amount of time.
The GUI, I mean, it brings stuff that would be the preserve of specialised data guys down to the level where somebody that can't sit at a command prompt is capable of doing these things. So it is really ridiculously accessible. There's so many things that we're finding that are beyond the ability of the human eye to define, beyond the ability of the human brain to comprehend a pattern that is so convoluted and complex. This is where AI will really show the benefits. It will push things forward further, and it will do so faster.
I've always had a passion to improve standards of care through personalised medicine, and here with the tools that we're developing at OCB, powered by the IBM systems, we are looking to make a tangible difference to standards of care in cancer.